Today you will learn about very important types of scopes, what we call the local and the global scopes. Remember, when we say a variable scope, we are referring to the part of the program where a variable is accessible. So if a variable is accessible, it means it is within our scope. Remember also there is nothing like a block scope in Python, like in C++, for example. We have no block scope. By that we mean is, let's say line number 4, assign the variable lucky number within this block. Will this number be visible outside the block? The answer is yes, it will be visible outside the block. That's why we don't have this block scope thing. If you didn't assign it, it will definitely give you a name error. This is what we learned already before. Today we would like to learn about details about the scope. The variables that we were defining before have something we call global scope. Global scope is something defined on that very global level. But the variables defined assigned inside the function, we call they have local scope. Local means like limited view. The scope of a variable defined in the function is within the function only. So if you try to use this look1 outside like here, you will get a name error that no one know about that. The global is visible everywhere in the program. The local is only visible inside the function. You shouldn't try to use the local one outside the function. It is defined in the whole function here, so it's visible here but not here. Let's do some tracing. We define a variable here outside of function, so this is global one, and then we call function f. Function f doing some assigning to the variable local, so local here is a local variable. We are printing it, then we can also print a global. The interesting thing here is, I would like you to get a sense that the interpreter is going to follow some steps to decide if the variable is local or global. So when we say here print a globe, the first thing is going to search if it is local variable or not. If it's local variable, it will use the local variable. If not, it's going to go outside the f and see if it is global variable or not. So first check if it's local, otherwise check if it is global. Let's see an example that is stressing this point. B and C here are both global variables. Here inside f, we are saying b equal. Once we have something that is doing an assigning inside the function, then this is a local variable. So notice here, b existing in two locations. We have a local b and we have a global b. Now here, c is a global variable and it isn't assigned in the function, so it's still a global variable. C value is 6, 6 plus 1 is 7, b is 7. But which b is 7? The special local b that is here. So when we print b, is going to print always 7. Now, here, this is tricky. If you say print b, what's going to happen? It's going to print the 20, not 7. Why? Because this b is outside the function, so it doesn't know anything about the local b here. It only know about the global b that is here. Otherwise, if you try to assign the b with a returned value from here, it's going to be reflected here. So the moral of that is, what is inside the function is local. It isn't visible outside. So this b only see the global one, so always will be 20. Inside the function, there is the local b, so it will be considered the first, because b exists in the local scope. Another relevant thing is, what if I would like to assign b inside the block, but still I would like that to affect the global b, not the local b? To do that, you can use the word global b this way. This statement will tell the interpreter, when you see a b, consider it the global one. Now, when we assign here b to 6 plus 1, which is 7, even outside the function here, when we print the b, it's going to print 7, because the value of b changed. B here is a global b, b here is a global b. But going a step back, b here is a local b, because it is assigned locally inside the function. Overall, there are 4 types of namespaces. We learned today about the global namespace and about the local namespace. There is also what we call enclosing. We will study it a bit later. And there is also what we call a built-in space. So in built-in space namespace, The scope includes all of the things that are already defined for you. Remember the len function, int function, max and sum, the type error, and so on. All of this built in and ready to use things for you. And as I said before, when a variable is used in a function, the Python has some searching. It first asks if it is local. If local, it's going to use it. If not local, is it enclosing? If enclosing, use it. If not in the enclosing, is it the global? Then use it. Otherwise, is it in the built-in? Then use it. If it doesn't exist in the four types of spaces here, or namespaces or scopes, is going to give you an error. If you would like to see what kind of variables is visible within a space, there are a bunch of functions for that. You can print this function here, or print globals, or print locals. You don't need to care about that at the moment. The last thing that we would like to discuss is what we call constants. First of all, the more we go during the course, you will know that using global variables is a very bad practice, and it causes problems and conflicts of names and so on. Sometimes I use them either for simplicity or for educational purposes, but in practice we don't use them. One good use case for global variables is what we call a constant. A constant is a value that no one has an intention to change. For example, thinking about pi is 3.14. Or let's say you have some max value in your program and you would like to define. Typically, if you would like to express an intention about that, we define the whole variable as capital letters. So when you read a code and find someone assigning a variable and all of its letters are capital, he means that, guys, this variable is capital and please no one change it. An example for that might be like, say, computing the area of a circle. So you define globally that pi is 3.14 and then you are using it. Notice that we can change the variable here. We are allowed to do that, but as a programmer you shouldn't. In a language like C++ or Java, if you can define a constant and no one will be able to change it. But in Python we depend more that people are more mature and adult and know what they are doing. So it's different philosophy. That's all.